Hey guys, so we spent the last 2 weeks looking at how to find the measure of an angle in degrees and radians, and we said an angle is formed when we have the terminal side that rotates either counterclockwise around my circle or clockwise around my circle that forms a positive or negative angle. So today we're going to look at how an angle also on a circle also forms an intercepted arc and a sector. So let's do some quick look at some new vocabs. The definition of a sector, you can think of a sector as a section of a circle. So it's a portion of a circle that is comprised of two radii and an intercepted arc. So here you have the sector, a section of my circle, formed by a central angle. Central angle is an angle where the vertex is at the center. And apart from this angle forming a section of the angle a section of the circle that we can find the area of, it also forms an intercepted arc. And we can talk about an intercepted arc, or the arc length of a circle, as being the distance. This is the arc length, the distance that is part of the distance around the entire circle. So the distance from one point to another around a circle is the intercepted arc. Depending on where my terminal side of my angle ends, your intercepted arc could be small or large, right? And if my angle covers the entire circle, 360 degrees or 2 pi radian, then the distance around that circle, that intercepted arc, will be our circumference. And we're familiar with how to find the circumference of a circle. So before looking for an arc length formula, let's define some variables. In this section, we're going to say that R is the radius. We're going to use R for the radius. We're going to use A for the area when we're looking for the area of that sector. And we're going to use lowercase s for arc length. Lowercase s is generally used for arc length. And then we're going to use theta to represent the measure of the central angle. Okay, so this right here is our theta. And it's important to know that in the formula for finding arc length and area of a sector, theta is always in radians. And it needs to be in radians. So if we have an angle in degrees, we have to convert it to radians. So let's start with the formula for the circumference of a circle, and then we will use that to derive the arc length formula. So you're familiar from geometry, you might recall that the distance around a circle, we call that the circumference, can be found by 2 times pi times r, right? That's this distance around any circle is 2 pi times its radius. And so r is our radius. And I want you guys to think about what this 2 pi actually represents, because before you just remember the formula as, circumference is 2 pi r, right? But actually the 2 pi represents the measure of the central angle. And because we're looking for the circumference, the distance around the entire circle, the measure of the angle that covers the entire circle in radian is 2 pi, right? Remember that one full circle is 360 degrees. 180 degrees is pi radian. And so 360 degrees is 2 pi in radian measure instead of degrees. And our angle always has to be in radian measure for finding arc length and area of a sector. And so if I don't want the distance around the entire circle, what if I only want the distance around a part of the circle? So I only want this small distance. Okay, so I'm going to say arc length S is going to be equal to, and it's going to be the same formula. Instead of 2 pi, which covers the degree of the arc of the angle that covers the entire circle, we're going to say that this is my angle theta. So arc length is equal to theta, whatever this angle may be, times the radius. Okay, so really the same exact thing, except circumference is the distance around the entire circle, arc length is the distance around a part of the circle, and for circumference, since we have the entire circle, my angle is 2 pi radian, and for the arc length of just a section of my circle, my angle is going to be theta, whatever that angle is. So S is equal to theta, that angle has to be in radians, times the radius. So let's look at an example. We want to find the arc length of each sector. So our goal is to find the length of this distance, which we're going to call S, and in the second circle, the length of this distance. Again, we're going to call that S. Okay, so we're just going to use the formula. The arc length is equal to the angle theta times the radius. And just remember that theta has to be in radians. And in this case, they do give me my angle in radians, right? So I'm all set there. Arc length is equal to my angle, my central angle is 2 pi over 3 radians times the radius, which is 17 miles. So I'm just going to put 17 there, which is really just 17 over 1 if you think about that as a fraction. And then when you multiply fractions, you just multiply across. We're going to leave our answer in exact form, so in terms of pi, so I don't have to round. When I multiply across, I have 17 times 2, which is 34. So 34 pi over 3 miles, right? Distance in miles. And so that's our exact answer. That's the distance of this arc. 34 pi over 3 miles. And if you want to put into your calculator, you can certainly round it just to visualize what it is, but we're going to leave our answer in exact form without rounding. So we're going to leave our final answer in terms of pi, but that's roughly 35.6 miles. Okay, that's the distance around of that arc length. Okay, so if we look at the next one is very similar. Looking for the arc length, so start with the formula. S is equal to theta times r. And now in this case, the only tricky part is they don't give me my angle in radian, and I need my angle in radian. So I have to do a little bit of converting, right? So let's start with on the side, we have to convert from degrees to radians, which is what we did last week. So we start with 225 degrees, and remember, to convert from degrees to radians, we're going to multiply by a special 1. So this is over 1. And my special 1 is going to be, since I want to get rid of degrees, I want to cancel out degrees. So I'm going to put 180 degrees in the denominator. 180 degrees is the same as pi radian. So that's my special 1. And then that way my degrees cancel out. And then 225 divided by 180, we can reduce that. And that's going to give me 5 pi over 4, right? 5/4. 225 divided by 180 will give me 5/4. So 5 pi over 4. 225 degrees is the same as 5 pi over 4 in radian measure. And so that's the angle that I'm going to put into my formula. 5 pi over 4 times the radius, which is 8 over 1. Okay, and then I just multiply across. Or you could do 8 divided by 4 first and then times 2. Or you could do 5 times 8, which is 40, divided by 4, which is 10 pi. So the distance of that arc that is formed by the 225 degree angle is 10 pi feet. That's my unit. All right, so same formula to find the length of any arc. Arc length is the central angle times the radius. Make sure that the angle that you're putting into the formula is in radians. So if they give it to you in degrees, you have to convert it first.